Hello everybody, welcome to this video where we are going to discuss standard form of Boolean functions. So in our previous lecture we had discussed about the canonical form, of Boolean functions, and there we saw that a Boolean function can be represented as the sum of mean terms and product of max terms. So both these representations, whether it is sum of mean terms or product of max terms, one thing is sure, that the terms do not contain minimum number of literals. So if I have a function which I want to represent using a sum of mean terms or product of max terms, it must have all variables. So if f is a function of 3 variables, so suppose I write like this, f of x, y, z, 3 variable, then I should have something like this. Say x dash y, z. So every term should have all 3 variables either in the complemented form or in the uncomplemented form. The same goes also for the product of max terms. So I should have all the terms, that is all the literals in each term. So this is, say, sum or a product of sums format. So definitely the terms, individual terms in this representation does not contain minimum number of literals. So we have another way of representing this, and this is known as the standard form. Standard form. So this also has got two forms. Okay, sum of products and product of sums. Don't confuse this with sum of max terms and a sum of mean terms and product of max terms. Okay, this is sum of products and this is product of sums. So if we consider the sum of products, okay, this is a function can contain, say, something like this, which is each term here now is a product, okay, and together you have they are joined together, each term is joined together by the OR operator, which is the sum, and each term is a product, and actually it is nothing but the AND operator. So this format, if you have something like this format, then this is known as a standard format. Okay, and one thing you can notice that here the terms, then each term can contain any number of literals. It may be one literal, 1, 2, 3, and so on, depending on the number of variables. So each term can contain any number of variables or any number of literals. So this is a sum of product. Similar to this you have the second one, which is the product of sums. Product of sums. So I may have another function, say f1, which I can write it as x into x dash plus y into x plus y plus z dash. So here each term is a sum. This is, each of this is a term. Each of this term is a sum, means it's a OR. They are connected, the literals are connected by OR, and all the terms are held together by the AND operator, which is nothing but the product. So OR is the sum, this is the product. So product of sums. Product of sums. So this is your standard form. So if I give something like this, f is equal to x y z dash plus x dash y z plus x y z dash. Okay, now this is in the canonical form. Okay, this is in the canonical form. Why? Because all three variables are present. Okay, here it would be more clear if I write, if instead of just writing f, I write f of x, y, z. This tells me how many variables are there. Because I may have an expression where there is no one variable doesn't appear, even though it doesn't make any sense. So this is in the canonical form, but it is also in the standard form. It is also in the standard form in the sum of product form. Sum of products form. Okay, but if I have something like this, f of x, y, z, x plus y, z plus x, z dash. Okay, this is not in the canonical form. This is not canonical, but it is in the standard form. It is in the standard form as a sum of products, SOP. Similarly, we can also have our functions of x, y, x. Let me just take two variables, x and y. So I may have x plus y dash into x dash plus y. Okay, this is canonical. Okay, this is also standard. Similarly, I can have x, y, x into x plus y dash, x dash plus y dash, x plus y dash. Okay, so this is in the standard form, but is it in the canonical form? No, because this term contains only a single term, so it is not in the canonical form. So this representation is your standard form representation.